Imagine a small assembly line responsible for packing individual baseball cards into packs and individual packs of baseball cards into boxes. For the purposes of this discussion, we'll assume that there are 10 baseball cards in a pack and 10 packs in a box. So we have this conveyor belt where individual cards roll to the person on the right who collects them while he has less than 10 cards in his possession. When he has collected 10 cards, he packages them into a pack and passes it on the conveyor belt to the neighbor to the left of him. He then continues to collect individual cards until he again has the 10 required to form a pack, at which point he packs them up together and again passes it to the neighbor to the left of him. Now, in order for him to do this, he will need to keep track of how many cards he has in his possession at any one time. Since whenever he has collected 10 cards, he forms a pack and gives them all up, he will never hold on to more than 9. He therefore only requires digit representations for the numbers 0 through 9. Now we can use a variety of different symbols to represent the numbers 0 through 9, but you're probably used to seeing the following. The frames that are being displayed now show the person on the right collecting his first pile of cards to form a pack. The sign that he holds up represents the number of cards he has at that moment in time. His neighbor to the left of him does the same thing as him, only she does it with packs of cards and forms boxes instead. In other words, she collects all individual packs delivered to her until she receives 10 of them. When she does receive 10 packs, she packages them into a box and passes it to the neighbor to the left of her. She then continues to collect packs until she receives 10 again, at which point she will package them up and pass them on to the neighbor to the left of her. Even though she holds on to packs instead of individual cards, she too will only require digit representations for the numbers 0 through 9, since she holds on to up to 9 packs. In the animation being shown, the packs of cards are the squares surrounded by a red border. The individual collecting the packs is holding up a sign representing the number of packs she has. Notice that individual packs of cards are rolling to her on the conveyor belt from the right of her, just like individual cards are rolling from the right of the person collecting them. Now suppose the neighbor to the left of her continuously collects boxes until he receives 10 of them. When he receives 10 of them, he packages the 10 boxes into a bag and rolls it to the neighbor to the left of him. If he also keeps track of how many boxes he has, he too will require digit representations for the numbers 0 through 9. The single box of baseball card packs appearing in this animation is orange, and the bald stick figure surrounded by the 2 stick figures with hair holds up a sign representing how many boxes he has. In order to avoid drastically increasing the length of this video, he will only be collecting 1 box and will not be forming bags. However, you can imagine how this assembly line would continue its operation. In this system, each person carries out the same process, whether it be with cards, packs, or boxes. That is, each person is responsible for collecting and keeping track of how many objects he or she has until the individual receives 10 of them, at which point he or she is responsible for packaging them and passing it on to the neighbor to the left of him or her. After the individual has passed on a package of his or her collection of 10, he or she starts from 0 and repeats the process so long as he or she continues to receive objects. Now that you have been shown this assembly line in action for a while, notice how we are representing the numbers we have by comparing the headline text to the digit combinations. Every time a baseball card rolls on the conveyor belt, we are increasing our number of baseball cards by 1. This is reflected by headline text that says the number we had on the conveyor belt to the number we have now. When every object on the conveyor belt is in a person's possession, and no person is holding more than 9 objects, the headline text mentions a single number, and its representation is shown by combining the digits of each person in the order shown. Notice that the person collecting individual cards starts by holding up a sign for 0 right away, but everyone else does not immediately hold up a sign with 0. This is because we only need a person to hold up a 0 as a placeholder. For example, when a single box and 2 cards have been collected, the person who collects packs needs to hold up a 0 sign to represent her presence so that we know that the digit for 1 does not correspond to having a single pack, but rather a single box. Now there was no mathematical reason to stop at bags. We could have continued with shelves of 10 bags and bookcases of 10 shelves, and continued this process of each person on the assembly line collecting objects from the person to the right of the individual until he or she receives 10 of them, at which point he or she packs them up and passes it on to the neighbor to the left of him or her. We could have also used DVDs or t-shirts instead of baseball cards or any other item that we wanted to count. The point is that each person collects packages of 10 from the neighbor to the right of him or her and delivers a package of 10 to the neighbor to the left of him or her. Therefore, the person all the way on the right of the assembly line collects individual cards. The neighbor to the left of him collects packs of 10 cards, whose neighbor to the left of her collects boxes of 10 packs with each pack containing 10 cards, or boxes of 10 groups of 10 individual cards, whose neighbor to the left of him collects bags of 10 boxes with each box containing 10 packs and each pack containing 10 individual cards, or bags of 10 groups of 10 groups of 10 individual cards. Got that? It might sound a little cluttered, but all we did is open up all of our packages until we got down to how many individual cards we have. Now the representation of the number is then formed by joining together everyone's digits, assembling them in order of the size of the package that the person collects, with the leftmost digit representing the number of largest packages that have been formed, and the rightmost digit representing the number of individual items being counted. Our words for these numbers makes packages of 10 the natural choice to use, since we can break up the words for numbers into pieces to figure out its representation. For example, 123 represents that we have 1 box of 10 packs, 2 packs of 10 cards, and 3 individual cards. However, there was nothing mathematically special about 10.